All right, welcome back to Lag Demon Programming. In the previous video, we set up an interface to have interactable objects, and we set up our character to interact with objects. And in the meantime, because this really isn't an asset-based tutorial at this stage, I've created an asset here for us. Actually, I didn't entirely create it. I got this from Megascans, and I set it up as a blueprint. And I'll at some point in time go through that kind of process, but it was really mostly just doing some manipulating in Blender to make pivots work and stuff. But it doesn't do anything just now. If we come in here and we come over to this chest, you see we've got our E for interact key, and you see down here in the thing it is hitting the BP chest object, but the chest isn't doing anything. So we want this chest to open when we interact with it. So how are we going to do that? So the first thing we're going to do, I'm going to close this output log for now. And we are in Unreal Engine 5. I'm going to come down here into our C++ classes. I'm going to right click, create a new class. And this is going to be just an ordinary actor class for our purposes, but we're going to implement that interface that we just created in the previous video. So we'll click next, and I'm going to put this in a folder that I'm going to call actors, and I'm going to call this actor class is going to be something like we're going to call it Openable Actor. So many things are openable, right? Doors are openable, cabinets are openable, chests are openable. All these different things are openable, and they have a couple of common characteristics. You can open them, you can close them, and both of those stem from interacting with it. So that's what we're going to create, is this openable actor, and then we're going to derive our blueprint for that chest from openable and set up some very simple things to cause it to actually open and close when we interact with it. So let's create this class, and once again, it's probably not going to compile right off the bat. I'm going to have to go in and make that little adjustment because I did put this in a subfolder. So I'll pause the video and I'll be back when this is all ready to go. Okay, so it finished, and of course it errored because of this same problem right here. I'll eliminate that. This is our openable actor now. And these things are not going to need a begin play or a tick, at least not in here. We do want it to be interactable, so to do that, we always want to, I don't know if I mentioned this, whenever you add include files to a CPP file, make sure they are above this generated header file. Nothing, you can't put any include statements below this header file, or it will, this generated header file, or it will error. Include, and this is going to be slant interfaces interact.h, and we're going to go comma public I interact. That's what we called it, right? Yep, interact. I interact. Okay, good. So we're going to want to implement that virtual void interact. I believe I called it interact CPP. And we will implement that one. And we're also going to create a couple of blueprint implementable events. So this is going to be U function, and it's going to be blueprint implementable event. We'll give it a category equals events, and we're going to call this void on open and we'll call this on close. And then we're going to create a U property. And we're going to make this one blueprint read only. Category. And we'll call it state. And this property is going to be bool is open. Oops. And we'll set it initially to false. So we don't want the blueprint changing this because we're going to determine this state. And we're going to call the appropriate function here from our interact. So let's go over to the CPP file. And let's implement those two functions. Void. It's going to be a openable actor colon open colon interact CPP. Oh, let's go. Let's go back to this header file. This needs to be flagged as override. And that's interact CPP in case I got that wrong. Interact CPP. Yeah, I got it right. So what we're going to do is check the state of it. So we're going to say if is open. We're going to call close. Else we're going to call open. But if it is open, we're going to say is open equals false. And we're going to say is open equals true. And that's our interaction for this openable thing. So let's make sure that this compiles. And I will be right back. All right, I'm back. A couple of errors here. This is supposed to be on close and on open. You were probably screaming at the screen while I was doing that. So having fixed that, go back and recompile. And I took the begin play and tick out of the header file, did not take them out of the CPP file. And it compiled successfully. So now we can start working on the blueprint for this thing. So here's the initial blueprint that I created in a folder called, nope, not there, in a folder called blueprints under items. This is, I'll just show you this. This is the storage chest. It's all the assets for the storage chest. I downloaded this off of Megascans. And then I just had to make a little adjustment to the lid, and this has a bunch of level of detail models in it. I'm only using the one LOD 0 right now, and I created a new lid, an additional lid for it that has a different pivot point. That's all I changed was the pivot point, so I could get it to rotate. And I'll show that to you. So if we go over here and open up this blueprint, over here to the viewport. All I did was add the two meshes in. The lid mesh is parented to the chest mesh, so when we move it around, they all move together. The chest mesh is the root of this. That's important to always have the main mesh of these types of blueprints be the root. And then the lid mesh is parented to it. And I just changed the pivot point of the lid mesh, which meant I had to position it on here. But that's okay because now we can rotate it here around that pivot point. And the only strange thing is that because I didn't rotate the pivot point, I have to go from 360 degrees down to 270 to open it because of limitations on how you can set a rotation on this, but that's okay. We're going to go over here to the event graph, and this is going to be very simple. But first, we need to go up here to class settings, and where it says parent class actor, we now want to change this to openable actor right there, and we will compile and save that because that's going to give us access then to those events. So we're going to look in here for first of all, no, it's called on open event, and on close event. Yes, of course. We need to change our character class a little bit before we can do this. It's just a minor change. We actually have to find this object and call its interact event from that class. So I just confused myself for a moment. So let's go to our character, CPP, and here where we're doing this log, we don't want to do this log. What we really want to do now is interact with this. So we don't want to just get the actor. What we want to do is have this an I interact, and we'll call it interaction, interact. And we want to cast this to I interact, hit result. So if this cast succeeds, let's make sure we've got this interact. Do we have it? Did we? We need that header file, so we need to pound, include interfaces interact.h. There we go. So that now we can cast this actor to this interact, and if this cast succeeds, this will be non-null. So then we can just call interact pointer interact CPP. No. No. Lowercase. That's probably why I couldn't find it. That should, if we're interacting with our chest then, if we go to our openable CPP, should call this, interact CPP. That's what we want to, this is our interact CPP here. We want to call the interact CPP on the interface. Interact.h. Yes, interact CPP is the one that we want to call on this interface, and when we go here to openable, this will get called. Is open will get called, or on close will get called, or on open, depending on the state, and the state will switch. So that should do it, and I have to recompile now. Hopefully this will work. So we'll compile. We didn't change any header files, so it should compile fairly quickly. So if you just change the CPP file, it really doesn't have to regenerate a lot of stuff. It's only when you change some of these header files, it regenerates a lot of material that needs to be recompiled, so it can take longer. So we'll see how long it takes here. Shouldn't be too long. I'll pause the video and be right back. Okay, we have a successful compile. So now we can go to our BP chest, and for the moment, let's do this on open. Let's just do a print string. Let's just make sure things are really working. And close here, we'll do another print string, and what we'll say here is just on open, and we'll say on close, and see if it's working. We'll compile and save this, go back to here, we'll hit play, we'll come over here. So now when we come up to, oh, you know, before I do that, got to open the output log. There it is. Now we'll hit play. So coming up and pressing E on these things doesn't do anything anymore because it's not our interactable thing. But pressing E on this says on open, then on close, then on open, on close, on open, on close. Okay, so far so good. So what's happening is our event that we set up, our interact event that we set up in here is being called. It's being picked up by our character class in C++. The character class is shooting out that ray trace through the center of our camera. It's hitting this box. It's saying, I found something. What did I find? It's casting it to the iInteract interface. That cast is succeeding. So it is passing, it is calling the interact function on the box through the interface. The box then, right here, is picking up the interact and it's looking at its own state. If it's closed, it's firing the on open event. If it's open, it's firing the on close event. And when it does those, it's switching the state automatically for us so that it calls these alternately. And that works. So let's get rid of these print strings. And now let's make the lid open. Why not? We need a timeline. So we'll add a timeline. And we're going to do on open, we're going to do a play. And on close, we're going to do a reverse. Now, I'm not doing play from start or reverse from end because I want this to trigger whether it's completely open or not. So we can just hit E and it'll start to open, and we hit E again, it'll turn around and start to close. Okay, so let's go set up our timeline. And for that we need a float value. And we'll just, I think about 1.5 seconds is probably enough. So we'll add a key there, and we'll add a key here at the beginning. And we'll set these keys up now. So let's select this key, make sure that one's selected, and we'll set this to a time of 0 and a value of 0. And we'll click on this key, and we'll set it to a time of 1.5 seconds, and we'll set it to a value of 1. That'll be fully open. And then we can just click these and get our timeline in here. Now, I don't want this to be linear either, so I'm going to change this to, I think, user, and we'll make it do something like this here, and we'll change this one here also to user, and we'll do something like this. Let's flatten this out just a little bit more. And so it'll start opening a little slowly, and then it'll speed up, and then it'll slow down, and it'll ease into place. And that should look really nice. So we'll just compile and save that graph. And now we have a value coming out of here. Oops, I didn't want to do that. I want to open up that blueprint again. Want to go back to the event graph. So now what do we exactly want to do? We want to take this lid mesh here. We want to get this this component out. And if we look at this viewport and go to this lid mesh here, it is this x-axis that we want to rotate. Okay, and it's starting at this 360 point, and we want to go to about 270, maybe a little beyond, maybe open out a little bit like that. Let's zoom in here a little bit. Let's fly in so we can see. Yeah, I think it should lean back a little bit like that. So that's about 230. Let's make it even at 235. So we want to go from 360 to 235. So let's set up a couple of variables in here, and that'll make this adjustable as well. But we'll set this to start. No, we'll call this closed angle, and we'll change this to float. And we'll create another variable here. We'll call this the open angle, and that's already a float. We'll go ahead and make these editable so that a designer could change them if they want to a little more easily in game, or not in game, but they could change them in the design of the overall level when they're putting these down. Okay, so let's set we got to compile first, and then let's set these defaults. So the closed angle is going to be 360, and the open angle is going to be, we decided 235, right? Okay. So what we want to do is lerp between the closed angle and the open angle according to this alpha. And you know what, I should go, let's change this new track name. Where do you change the name? Rename. And we're going to call this lid driver. Okay. So now we've got the lid driver. That's going to go into the alpha. So we've got the closed angle, the open angle, and this lerp. Lerp is linear interpolate. So what it's going to do is it's going to move this output value from the closed angle to the open angle according to where this alpha is on here. And then what we want to do here is set, we want to get the set relative rotation. That's what we want to set. Well, we don't want to change these, so let's split this structure pin. Okay, and we want to also get relative rotation, and we can split this struct pin. So the Y and the Z we want to leave alone. We want to set the new rotation of the X to this. And I want to move this stuff down out of the way and hook this update into this set relative rotation of the lid mesh. That all looks reasonable. Let's clean up these lines just a little bit. Just don't like things crossing over too much. Sometimes it's unavoidable because of the way they've arranged things. That's okay. Let's compile and save that. And let's see if our little animation works now. Possibly not. Let's do a file. Save all. There are just some aspects of Unreal Engine that seem to take an awfully long time. Like saving. But I do realize there's a lot of stuff going on and it has to save it. So let's hit play. And let's go over to our chest here. and hit our E key. Whoa. Okay. So obviously I chose to do something wrong there. I know the closed angle is 360. And the the open angle is supposed to be set to how did I get those wrong? The open angle is supposed to be 235 and the closed angle is supposed to be 360. Now, how did I get those? I thought I typed those in correctly. Okay, compile, save. Let's go back to here. Let's try again. See if it behaves a little more correctly now. Go here. Hit E. Ah, the lid opens. Hit E again. And the lid closes. There's a little delay there for some reason. If we start to open it and then hit it again, it closes. Okay, I'll stop playing with it. Okay. So that's working. So we can now open and close the chest. So the whole point there was when this event fires, it plays. When this event fires, it reverses. And I use this reverse and not the reverse from end because it starts right where it left off and starts going backwards and plays same way so it can open and close. We could lock it so that once you hit E, nothing happens until it fully opens and then you have to hit it again. Another thing that we can do with this is we can come across this with this finished and use that to pop open a display that will display the inventory of the chest along with our own inventory and allow us to transfer items and so forth. We could do all this in C++ as well. It's entirely possible to do this in C++, but my preference personally is to reserve C++ for abstract concepts and make them as general and as useful as possible so that a designer can create something as simple as this in Blueprint to just open and close the actual items. So, you know, this same openable object, we can create another blueprint of a door and use the same exact mechanism, but the angles would be a little bit differently and the axis would probably be a little bit different. There'd be minor changes to this. The designer can do that. and we'll be able to reuse our class for opening and closing things. And then pop open the appropriate inventory. And we're going to have another class for doing that set of tools written in C++ that'll make it very easy for the designer to open the inventory and show their display of the inventory. You know, the display stuff is going to be largely up to the designer how it's displayed, but the data items that they get to put in their display will come from our C++ code when we get to that portion of it. So it's all working. And let's just try it out one more time. So that's it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And I will see you in the next video. Thanks for watching.